Okay, we might just get started then, and everybody else is going to trickle their way in after they've seen the posters. So before we begin, I would just like to remind our presenters that they have 7 minutes to present, and you will have an additional 3 minutes for Q&A, where we'll hand over to the evaluation panel and we'll invite questions from the audience. So please keep an eye on the traffic light system. So when you have 6 minutes finished, the amber light will signal. So without further ado, I'd like to invite Dr. Ken Thomas, Head of School of Engineering. Ken, if you'd like to come up to the podium and invite your students. Thank you.
Okay, thanks, Emer, and thank you again to everybody involved in today's research day. It's a tremendous achievement, and I think, did you say it was the 6th, Peter, this one, is it? So it's fantastic to keep it going. Very important day on the calendar. I love the words connect, innovate, inspire, which is kind of what we're all about, and part of the 4 presentations here is about connectivity between the School of Engineering and indeed other schools and other disciplines, and the School of Science in particular. So I think that word connection is great, just even to walk around the posters outside and see all the various ideas that are happening and all the various research. And you can start to join dots quite quickly and see connectivity across the Institute, which is fantastic, between the different schools and indeed with industry and other partners also. So congratulations to everybody involved. Our first speaker here this morning is Mangalika Bhattacharya, who's supervised by Dr. PJ Craig and Dr. Kieran Murphy. So PJ is based in the Department of Engineering Technology, and Kieran's in the School of Science, so and Computing. So it's great that that's even connecting the two schools in that sense. And Mangalika is going to talk today about our research in mathematical modelling of magnetic nanoparticles in biomedicine. So over to you, Mangalika.
Thank you, Dr. Thomas. Today I'm going to present my research, that is mathematical modeling of magnetic nanoparticles in biomedicine. My supervisors are Dr. Craig and Dr. Murphy. Now my research is fairly theoretical in nature, so I'm going to divide it in various sections and present each as we go along. So first is, what is magnetic nanoparticles and why it is used? Next is, what is biomedicine and why magnetic nanoparticles are used in biomedicine? And the third one is, what is mathematical modeling and why we are doing it? So magnetic nanoparticles are basically iron oxide particles of sizes around 100 nanometers. They are recently being used in different biomedical applications, mainly because of the fact that they can be controlled externally by an external magnetic field, and the relative size of the MNPs are comparable to various biological entities like a cell, a virus, a protein, etc. The picture shows different ranges of MNPs that are being used in magnetic drug delivery. So the different applications of biomedicine that employs MNPs are as follows. Magnetic resource imaging, or MRI. In MRI, it's an imaging technique where MNPs are used as contrast agents, and they are injected into the blood vessels. And well, if there is a tumor or any other carcinogenic growth inside the human body, the tumor cells absorb the MNPs, while the healthy cells doesn't. So this concentration of MNPs at a particular location of the body creates a contrasting effect in a regular MRI scan, and the tumor is clearly visible, which makes it easier to treat. Next is magnetic drug targeting, or MDT. Magnetic drug targeting employs drug-coded MNPs, which are injected into the body, located to a specific part of the body, and then the drug is released. This technique overall reduces the probability of drug being delivered to elsewhere, like a healthy cell, and focuses on the required site. So this technique overall reduces the amount of drug that is consumed, so it reduces the cost, lessens the risk of side effects, and it reduces the recovery time. So next is magnetic hypothermia, which is our current focus of study. Magnetic hypothermia is an experimental cancer treatment in which magnetic nanoparticles are heated by an alternating magnetic field. So it's in a much similar way as a microwave oven heats the water molecule in a food. So the magnetic nanoparticles are injected into the tumor site. They are heated with the changing magnetic field, and the tumor and the heating destroys the carcinogenic growth or any other tumor inside the human body. This treatment is still in clinical trial and has been introduced in different universities in the world, but research is still going on to develop this technique further. So why do we need to model this phenomena? Now, the heating that is generated by the magnetic hypothermia needs to be extremely precise and focused so that it only harms the tumor cell and leaves the healthy cell intact. So this requires a comprehensive model that would completely explain the phenomena and would predict and calculate the heating. So we have tried to model of many particles with different initial condition and different position with the applied field. We have done this by taking the Landau-Licious and Gilbert equation, which is the LLG equation. It's a simple equation which describes how a MNP behaves. M dot is the velocity acquired by the magnetic nanoparticle, M is the magnetization vector, and H is the applied field. H dash and alpha dash are different kind of constants according to the environment, like viscosity, etc. First term is the precession term, and the second term is the alignment term. If the field is along this direction, the magnetic nanoparticle, due to the precession term, moves around the field. Now, if the alignment term is not there, the magnetic nanoparticle will continue to move forever and will have infinite amount of energy. However, due to the alignment term, it aligns itself, and the energy that it dissipates while precessing and aligning is calculated by a simple formula of force multiplied by distance. Now, when we began this work, we were not aware of any other work that was going on in this area. But recent few months ago, we found out a paper by Chattel et al., who has published a model of magnetic hypothermia with one particle. So while deriving their work, we found out our method of calculating heating and their method can be analytically derived from each other, which is also a validation for our model. So we have included the interactions in Chattel's model. As you can see, we have reproduced their model, that those are their published results, and we have exactly reproduced their model. And then we have included multiple particles with interactions in that model. Now we found out that if there are two particles and they have different initial condition and different position, at certain cases, the heating generated by two particles is less than the heating generated by one particle. However, so they sort of cancel each other out. However, if the position changes and the condition changes, the heating can be much greater than heating generated by one particle. So this result is still being validated and is still under still is a hypothesis. We have not included any result here, but we are going to present our results next month to a conference. So this is our preliminary work, which we have done yet, and that's it. Thank you. Questions?
Okay. Thank you, Mangalika. I think we have time for some questions. Does anybody have any questions? Don't be scared with the mathematics.
Thank you, Margarita. Are you assuming that the particles are always spherical?
Yeah, we have assumed the particles to be spherical.
And will that always be the case, or will it be practical to?
Well, the sizes we assume that to be extremely small, around 100 nanometers. So at that size, it is assumed everything would be a sphere, as dot. So I think it's in the practice.
Okay. And one other question: when you're heating the particles, are you assuming that they're static in position, or do they move around?
Yeah, we have fixed their position. They are not moving at all. We can change in our model, but in the model it's fixed. Yeah.
Okay, and would that have a big impact, though, if they're moving slightly or vibrating, or?
Yeah, well, this is a basic model which we started from one particle and we are building it to many particles. So probably when we'll have a working model of this configuration, we can assume that they would move, because in reality, of course, they're going to move. So after we have validation check on our results, we'll move on to that.
Okay, thank you.
Thanks very much indeed for a very good presentation. I was just interested in two things. Can the mathematical model be used to modify the dose then that's given to a patient? And can it correct ultimately as well for, say, the size of tumour, say, as well, in terms of the quantity of nanoparticles that you might need to use?
Yeah, actually, well, we are not, that's in magnetic drug targeting. We are not coating it with any kind of fluid or whatever. chemical. The tumor that is going to be destroyed will depend not on the number of particles but on the heating. So we have to find out exact what heating we can produce by our model, 2 particles, let's say 3 particle, whatever. So we have to reach that aim, the particular amount of heating. Actually, human body cells, and the tumor cells specifically we have in our literature, we found that the temperature would be 46 degrees. So we have to target that, not the number of particles.
Thank you very much. Most impressive, I must say. I've seen the Landau-Lipschitz-Gilbert equation a few times, and I could never get to grips with it at all. And I think you're absolutely right. It validates the work that you do your own model from first principles, and then you find out there's another version by somebody else done in a completely different way. And not only that, but one can be derived from the other. I think that must be really satisfying. Is one more general than the other, or will you work in collaboration with the other group in the future, do you think?
That's still, that depends on my supervisors. We have to, first we need to finish what we started. Then if we have to move on to something else, probably we can contact them and talk about their work and our work, we can collaborate.
Okay, congratulations.
Yeah, thank you.
Okay, thank you, Mangalika. And Mangalika referred to the fact that she's travelling to, I think, Vancouver next month to present her work. So we wish her well with that, and indeed PJ. Our next speaker is I'll just get it here, is Deepak. Deepak Shamavedi, who's based in the SEAM Centre under the supervision of Dr. Paul O'Leary and Dr. Ramesh Raghavendra. I'll get the title here, but it's in the, excuse me now. The full title is Design of Microwave Components Using Direct Metal Laser Sintering. I'm not sure if you're aware of the fact, but Ramesh and the team in SEAM have probably a leading centre, if not the leading centre, in 3D manufacturing, additive manufacturing in the country, which is tremendous for WIT and for the School of Engineering and to everybody involved. And Deepak's research is part of that group now, which is very important. And we're looking forward to hearing Deepak's presentation. Thank you.
Hello everyone, my name is Deepak Shamavedi and I'm a postgraduate researcher in SEAM. I'm working on a project titled Design of a Microwave Components using Direct Metal Laser Sintering. I'm doing this project under the able guidance of Dr. Ramesh Raghavendra and Dr. Paul O'Leary. Now before I start, I must say that I'm very much pleased to be presenting my research in this podium in the arena of additive manufacturing, which is also known as 3D printing. Now DMLS, Direct Metal Laser Sintering, is an additive manufacturing technique which allows the user to print virtually anything. Now, DMLS is a part or a technique for additive manufacturing for printing metal. That's also the reason it's also known as 3D metal printing. Now, however, 3D printing is a misnomer. It's not actually 3D printing. It's a 2D printing technique layered upon each other again and again in order to create 3D printing projects. Now, the best part about DMLS is you just have to design a CAD model and give it a click, and your geometry will be printed in a real time. Now, after having the basic understanding of how DMLS works, our next step was to exploit the untapped potential of 3D metal printing in the area of designing microwave components. Now, like many other researchers sitting over here, my road to research wasn't that easy. I step up with a question, what to print? What is gonna be? Now, is it going to be any of the standard microwave components, which we have already known, or is it going to be something different? Now, I do have experience of working as an antenna design engineer over there in University of Birmingham, but still, the puzzle was still over there. Now, just because of the fact that this is my PhD, there has to be some standard. We have to set up a benchmark for the next coming persons over there. Now, in order to make a standard, we make 2 assumptions. First, our next component, or whatever we design microwave component, has to be utterly complex. Now, second thing, it has to be very much novel. So let me draw your attention to what we actually made. Now, the image which you are seeing on the screen is the world's first ever 3D metal printed Sierpinski gasket antenna. Now, this particular antenna is fabricated within SEAM Research Center using titanium alloy. Now, it may look simple, but is complex at the very same time. The stacked geometry on one upon each other makes it very much complex with a highly precise make joints as well as edges over there. Now, the question in front of us was one more again. Is one of its kind antenna best of its kind as well? The question still remains. Now, in order to ratify that assertion, we came with a wireless performance analysis test. Now, I can understand very much well that many in the audience won't be able to read this particular graph. But let's make it easy for every one of us to read. So I created a reference line between a bad performance and a good performance antenna. Shadow out the bad performance, make life easy. So there are two values in front of you, which is good performance. Now these values depict microwave frequency bands of an antenna on which your antenna usually works. Now there are two frequencies in the range of 4 gigahertz and 8 gigahertz, which actually means your antenna is working in the range of 4 gigahertz and 8 gigahertz, which means it's a dual band antenna. Now one of the application or one of the advantages of having a multi-band or a dual band antenna is it can address different application with one single antenna. Now for example, your mobile phone, it do have several antennas for GPS, mobile phone, Bluetooth, but still a multi-band antenna can be used one singly. Now the same thing actually happens. Now on the right-hand side, the lobe which you are seeing over there represent the radiation pattern related to those frequencies. Now the red signal which you are seeing is the signal strength of those antenna, which is very much uniform across the space, which means that antenna is an omnidirectional antenna, which radiates all over the space uniformly. Now this was one part of my project. The second part of my project was related to examining the mechanical aspect of my 3D printing antennas. Now, not many of the people actually know, but DMLS is not very much famous for its surface finish. It doesn't give you a very polished surface or a very shiny surface. There are roughness on its surface. So, as you can see from the white light interferometry images which I have taken in the SEAM Research Center, there are peaks as well as valleys. Now, they are very much typical of this kind of a manufacturing technique. Now, the surface roughness was certainly in the range of 0 microns to 15 microns. Now, above image which you can see is basically a scanning electron microscopic images of different orientation of my antenna along XY directions, along Z direction, along the edges. Now, my work is actually to examine the impact of surface roughness on the wireless performance of an antenna. At the moment, I'm working on this, so wish me luck. Now, the second aspect which I want to analyze is certainly microwave phenomena, which is known as skin effect. Now, what actually happens is at a higher frequency, current tend to distribute on the surface of an antenna, which means higher the frequency you are working, the current will tend to distribute on a very narrow surface or a very thin surface, which at the frequency of application which I'm using, the 7.5 gigahertz, it's certainly in the range of microns. And the material which I'm using at the moment is a titanium alloy, for which it's certainly in the range of 7.75 microns. Now, it may amaze you by the fact that if I just choose a polymer block and coat it with a thin metal layer, and I will find the exact same performance of a polymer antenna compared to the solid antenna. Now, by exploiting the fact that I do have a DMLS over there in SEAM Research Center, I exploited its potential in order to create hollow surfaces as well as lattice surfaces. Now, I'm not bragging about my project, but the thing is, this is the first time ever the user do have a choice of selecting an antenna according to its weight for a certain application. Now, for example, polymer are not, on one side, they are lightweighted, but on the other side, they are very prone to breakage. But if you go for a high strength to weight ratio, you have a choice of selecting either a hollow antenna or a lattice antenna compared to the other one. Well, before leaving this podium, I would like to thank my research group as well as research support unit for organizing this great event. Thank you so much.
Thank you, Deepak. I'm sure we have some questions. PJ? Oh, sorry. Felicity first, then PJ.
Thank you very much. Very interesting. I could see the theoretical implications. Can you just give us an idea of how this might be applied practically in terms of advancing the area?
Well, first of all, I'm really glad that you asked me this question, not because of the fact that I'm prepared with an answer. But the thing is, this is a multi-band antenna, which means a certain you can use this particular antenna for different applications. Now, this work was done as a proof of concept, because this is the first time when the DMLS is actually being used for fabricating a microwave component, and that too so much complex. Now, however, if you want to use it for a certain application, you can either choose vehicular application or mobile Wi-Fi router. All you need is to arrange for a space in which that antenna can be fit. Now, certainly, what I actually showed over there, if you just give me a second. Yeah, at the moment, it's working at the frequency range of 4 gigahertz as well as 8 gigahertz. I can tune this antenna to work at a frequency of 2.45 gigahertz and 5.8 gigahertz at the same time, which actually means you can use the same antenna for Wi-Fi, for Bluetooth, and other applications as well. I hope you answer.
Hi, Deepak. Thanks very much for a great presentation, and congratulations. Thanks. I just have a question, actually, on this slide here. Is that radiation pattern, is it simulated, or is that a measured radiation pattern?
No, it's a simulator at the moment.
Yeah. Okay, and you've good confidence that it is representation?
Yeah, actually, like we have done the S11 measurement results, and they are very much accurate compared to the simulation results. And we are just one step before, like prior, doing the radiation pattern measurement, and that will be done very soon, within a week.
Great. Okay. Best of luck with that. Thank you.
Anybody else? Okay. Thank you. Thank you, Deepak. Okay. Our third speaker in this session is actually from a different department at a different school. It's John Organ, and John is based in the Department of Computing and Mathematics. He's been supervised by Dr. Larry Stapleton. Not sure if Larry's here, is he, today? Yes, okay, not to worry. Yeah. So John's presentation today is on information systems through a socio-technical lens, a soft systems engineering approach to systems risk. John, over to you.
Good afternoon. I'm a postgraduate student in the Insight Centre under the supervision of Dr. Larry Stapleton. Right. That's good. Okay. Oh yeah. Okay. Thanks. My study is an exploratory study of risk management engagement within a systems context. Currently, technologists forget to remember that many of the concepts associated with technology and risk are socially derived every bit as much as technologically driven. The aim of this study is to produce a new knowledge model in the form of an ontology which reframes risk as a socio-technical issue. I undertook a preliminary study with risk management professionals in the Irish financial sector. This preliminary study was used to inform the literature, address gaps in the theory, and undertaken prior to the selection of research questions. It provided considerable insight into the research design because it was informed by both theory and empirical study. The following research questions were identified. Flowing from those research questions, two provisional theoretical models have been developed, the functionalist systems failure model and the ontology logic model, which will form part of the overall architecture of the ontology model developed in this study. Practical considerations prevented me from extending the provisional study to a full series of interviews. At the same time, the Irish banking inquiry was being undertaken by the houses of the Roughness, and it was felt as an appropriate case for study as part of my research. The interpretation of the case study will be guided by socio-technical theory and Burrell and Morgan's paradigms of social and organisational theory. Those paradigms are functionalism, interpretivism, radical humanism, and radical structuralism. Each are mutually exclusive and capable of generating a distinctive analysis of a given domain. Here's an example of an existing case study. Current theories on risk management are driven by a functionalist reductionist orthodoxy where the understanding of risk is a simplistic one where comparisons are made between biological and mathematical parallels. There has been a failure to recognize that the causes and consequences of risk are embedded in organizational structures as well as intertwined in social processes. The internet and networking technologies has blurred the traditional boundaries of analysis in systems development. The traditional boundaries being either a software project or a business unit. They have become too narrow at analysing all the ramifications involved and the dynamics involved with risk management and technology. Risk management has been largely ignored within the systems development field, and if it's not done so, it's done so in parallel with other development activities. Some of the information that I got from my provisional study was that it's understood, risk management at a management level, but it's not understood by developers. They don't see the big picture. Either that or it's used as a political instrument in an organisation that people have a tendency to cover their own back, cover the back of their colleagues, or question the mandate of those involved with investigating risk management incidents. There are some other reasons there as well why it's an issue. If a project goes out of kilter, if developers have to acknowledge their own failures, for example. What has been forgotten is risk takes place within an organisational context. Approaches need to widen in scope and the variety of risks in order to deal with the gap between the model and the deployment of systems. Technology has had a huge impact on the financial sector. Changes in workflows, the increasing of new companies on the market like Stripe and TransferWise are challenges to traditional financial services. In the financial sector, risk has been largely a defensive tactic. It's largely a regulatory compliance activity. And traditional fragmented approaches are no longer suitable in the current regulatory environment. This has been acknowledged in Basel II, which places technology risk on the same levels as other operational risk. We need to recognise today that whereas before you needed solicitors and accountants to do complex financial products and instruments, today they can be done using computer programs with information supplied electronically. We need to recognise risk management and technology and the dynamics at play and how they play out into the future. My study is to build an ontology. An ontology is a formal, explicit specification of a shared meaning or conceptualization. Now, what do I mean? When I say a conceptualization, I mean a model with its associated concepts and relationships. Now, a model is understandable to a systems development person if they've studied UML, ER, diagrams, etc. It's explicit, all concepts are defined, it's formal, it's machine understandable, and it's shared, so there's agreement about the ontology. The ontology I'm developing is a model of systemic risk which reframes risk as a socio-technical issue. It sets out the vocabulary of systemic risk in financial services. It sets out the concepts and the relationships between the vocabulary. As an ontology, the model is formal and machine readable, and it can be expressed as XML and it's usable in internet-based systems. The overall architecture of the proposed ontology is as above. As you can see up at the top there's the ontology logic model. You have Burrell and Morgan's paradigm of social and organizational theory. You have the provisional facets of risk I have identified in the literature. It's provisional, so I haven't put in the full ones, I didn't have enough time. The model, the ontology, will be developed using Protégé. It's a Stanford University application. It's an ontology editor and a system used to develop intelligent systems. Thank you. Here's an example of an ontology. It's developed for the biomedical devices. It deals with the variety of different ways medical conditions and or medical devices can be described and called amongst different people in different systems, and allows for the management of that. Thank you. Any questions or comments?
Brendan?
Thank you, John. Question about your ontology. You say you've used OWL, and I'm just wondering why did you need, or well, first question is it the OWL DL or is it OWL itself? Is it the description logic?
It's OWL.
Subset.
At the moment, we haven't developed the model yet. We're going through the testimony at the banking inquiry in order to build the concepts for that ontology. So we haven't actually gone through the actual building of the model yet.
And do you plan to use it to perform some kind of reasoning with the reasoning engine, or is it just as a model?
Just a model. Knowledge model that can be used.
You might be better in that case, because OWL can be quite problematic. We have some experience of using it to just use RDF.
Yeah.
It might meet your needs, and it's easier to sort of publish it in the whole open linked data world. So you want to, I'd be quite cautious about using OWL. The tool support is not that strong for it.
Okay, thank you.
Thank you very much, John. Could I just ask you a question about the definition of risk?
Yeah.
What way are you defining
risk?
Well,
we're looking at it from a systems-based perspective. So if you look at a lot of the techniques at the moment in systems development, they've got checklists and Octave and that. And what they do normally in the systems field, they take bits and pieces from each. So what we're looking at it is from a human-centered based perspective, human-centered as a human-centered activity. So we want to include the technical aspects and the social aspects of risk.
And what are your social dimensions?
The social dimensions we have, as my previous, the facets at the moment are reductionism, logical rationality, the social world, and evaluation matrix. Those are the provisional facets of risk that we're going to examine the banking inquiry for through Borrell Morgan social and organisational paradigms. That's where the social technical comes in.
Okay, thank you. Thank you, John. As we're setting up our final presentation there, I'd just like to introduce our fourth and final speaker for this particular session. It's Kriti Bhargava, who's based out in TSSG. Yes? And I'd just like to invite Kriti to the stage. Kriti has been supervised by Dr. Stepan Ivanov, I think, and maybe the team out there, the wider team in TSSG. She's based in the School of Science and Computing, and her presentation this morning, or this afternoon, is on collaborative edge mining. Thank you, Kriti.
Well, good afternoon, everyone. I'm in my second year of PhD, and I'm working under the supervision of Dr. Stepan Ivanov and Dr. Willie Donnelly. And today what I'm going to talk about is one of the recent papers that we've submitted to Wireless Days. And it talks about a fog computing approach. Since I don't have enough time to discuss the approach in detail today, I'm going to quickly brush through some of the topics here, and I will try to address any questions that you'll have later. I'm sure you've all heard about Internet of Things and, well, perhaps Internet of Everything, which essentially means that every object that surrounds you, from your phones to tablets to tabletops and, well, the chairs that you're sitting on, will be connected to the Internet to share data. But this will lead to lots of data that is being collected continuously and pushed to a remote server that we refer to as the cloud. However, if I come to the analytics side of this data, it all happens in a very latent state. It actually introduces a certain latency because of the sheer amount of data. Therefore, in order to gain real-time information from the data that you're collecting, a new computing paradigm called fog computing has been proposed. And what fog computing refers to is moving some part of analytics away from the cloud and closer to your network in order to get insights from your data. A number of approaches have been proposed for fog computing so far, but we're primarily interested in edge mining, which is a very generic approach. And what this proposes is that we carry out very lightweight edge mining tasks on the small sensors that we have within our network. Now, what this does is it not only increases your network intelligence by giving you real-time information, but it also reduces the number of packets that you send back to your cloud for analysis. This, in turn, improves your overall network efficiency, since that is one of the major constraints when we talk about sensor networks. Since our approach is based on edge mining, before I move on to that, I would like to explain edge mining in a little bit more detail. one of the techniques that has been used to realize edge mining is called the Spanish Inquisition protocol. And that's sure because, well, we don't expect Spanish Inquisition. So what SIP proposes is that we only send the unexpected information from the sensor network to the cloud. That is, it first converts all of the raw data into your application-specific states, and only those states which cannot be predicted on the sync node using an approximation model are transmitted from the network to your cloud. This reduces the number of packet transmissions and in turn improves the energy efficiency and intelligence of your network. However, one of the major drawbacks of edge mining is that it only considers analysis on each sensor in isolation to each other, which is contradictory to the fundamental nature of sensor networks. It kind of limits the application of edge mining into applications where we need data coming from different types of sensors, which brings me to our approach, which is the collaborative edge mining, where essentially we consider interaction between different sensor nodes within our network. It forms the basis for parallel and distributed processing within our sensor networks. In this approach, we actually divided the analysis in two different phases. In the first phase, every individual sensor runs a basic edge mining approach to first convert the raw data into an intermediate state. If an event is then detected on any of the sensors, it collects data from its neighboring nodes to integrate those two states and form your application-relevant state. It uses an approximation model to then calculate the expected value at the sync. If the difference between the calculated and the predicted value exceeds a threshold, which is epsilon, or the time since last transmission to the sync exceeds a threshold called T heartbeat, we consider the new state as eventful that cannot be expected at the sync, and we transmit the new packet to the sync node. We use collaborative edge mining for detecting heat stress in dairy cattle, since I'm working on the precision dairy project. And in our scenario, we considered three different types of nodes. The first one is a mobile node, which will be worn around cows, so it's called the cow collar. And since it's it's a very cow-centric approach of calculation, we refer to as the cow puting. Our second type of nodes are the worker nodes, and there will be two types in this case, the static temperature nodes and the static humidity sensors. This is a state diagram that explains how the analysis will take place. So for every sensing cycle, we will be calculating the intermediate temperature and humidity states using the raw values that are gathered by the sensors. If an event is detected, say at the temperature sensor, it collects the new state estimate for humidity, which is calculated from its neighboring nodes, in order to calculate the new THI value. Once that is done, it is converted into a smooth state estimate, or in order to get, which also considers the past estimate effect. It then calculates what is the possible predicted state at the sync using a local copy of the approximation model. If the difference between the predicted value and the calculated value differs by more than a threshold, we consider the new state as eventful and we transmit the packet to the sync node. Otherwise, our node will go back to the sleep state. We evaluated our approach using R analysis, and we compared the performance of collaborative edge mining to edge mining based on packet reduction percentage and also mean error, which here we refer to as the delay that can be caused in finding the true THI values as we are using approximation models. What we see is that for small threshold values, which actually corresponds to latency-sensitive scenarios, whereas edge mining has a packet reduction starting from 60%, the packet reduction in case of collaborative edge mining starts from 90%. The mean error in case of small threshold values is comparable for both approaches, but it is higher in collaborative edge mining for certain cases, as packet transmission is governed by 3 different thresholds as compared to 2 in edge mining. However, this can be controlled since we are setting threshold values based on the allowed error rate. We also measure the performance across the T heartbeat. And just to conclude, we present a generic approach for fog computing that can be used for many different applications in the Internet of Things. And it results in improved network efficiency overall while providing you timeliness of event detection. And currently, we're working on the implementation of a sensor network testbed for dairy farming. And we're also working on alternative approaches for sensor analytics. Thank you very much.
Thank you, Kriti. It's interesting to see that we're moving from being student-centric to cow-centric, but that's a new development in WIT. Have we any questions? Peter has a question.
Thank you, Kriti. It was very interesting. I was just interested in terms of how your type of model talks to other systems. Is your goal to standardize so that, because you can define that triggering mechanism as to how sensitive your system is going to be, but the most useful aspect of that is how does it then talk to other systems as well?
The only information that we need in any of the edge mining approaches is a certain knowledge of what application you're targeting. Once you have your application-specific logic, it's easier to set the threshold values as to what percentage accuracy you're looking for, or what is the allowed error rate, which is in a sense the delay that is allowed. So once you have your application-specific logic, the algorithm that we are using is quite generic, so it can be directly applied.
Thanks very much.
Just a question about when you move processing out to the edge, how about considerations of data integrity or authentication or privacy for that matter? Is that within your scope?
Well, it's not really, but the authors of edge mining paper do consider this aspect. And if you're reducing your data within the network itself and not sending the raw values, you're essentially improving the privacy of your data. So we're not really concerned with privacy here, but it sure improves in case of edge analytics.
Okay, so you consider the edge processing to be done by whoever owns the data. So if it's maybe the cow example is not particularly sensitive, but let's say it's human sensors, and it's say within the context of a hospital or some other kind of, or maybe a college campus, you consider that data to be processed within the domain of whoever owns the data.
Yes.
Is that a fair assumption?
That's true, but another thing with edge mining is that we are considering small sensors here, and it's not possible to offload the entire computation on these devices. It's only partial lightweight computations that go there. So it is for you to decide what kind of privacy and accuracy you want and what kind of data you actually want to store on the cloud for future analysis.
Okay, thanks.
Okay, I think that's it.
Thank you.
Thanks, Bridget. So that brings to an end this particular session on engineering and ICT. I'd just like to thank all of our speakers here this morning. We've wandered from mathematical modelling into 3D printing, into risk management, and then into the Internet of Things. So it's been a hell of a journey over the last 40 minutes. But it just shows you the breadth and depth of what goes on here in WIT and the various connections. So congratulations again to everybody involved in the RSU. And I'd just like to maybe show your appreciation to our four speakers again, Mangalika, Deepak, John and Kriti. I think I might be now handing over to Emer. So back to Emer. Thank you.
Thank you, Ken, and thank you to all our presenters so far. I now invite Dr. John Wall, Head of School of Lifelong Learning and Education, and presenter Sarah Bates to the stage. Thank you.
Do you want to change that? Okay, thanks. I suppose at the outset, I just want to say well done to everyone involved. I'll change the order a bit, maybe. I acknowledge the work of Susie and the team. Peter has picked up a great team in some respect in moving into that role, so well done. 6 years of hard, this has been ongoing. It's proof of a can-do attitude, I would say, and it's great testament to yourselves. Like, this has gone from strength to strength, having been involved in it a number of years coming to the event. So well done to all involved. Maybe to set the context, you've been pioneering, I suppose Sarah Bates here and Dr. Carlo Byrne are pioneering from our school's perspective, but that's building on a base, just to set the context that the school is a little bit different. So while you have one person here, realise that the school is somewhat different in the context that we don't have a single CAO student coming through the school. We have a Department of Education, so all our learners are different in the context of their typically mature lifelong learners. We're building from a small base, so just to be aware of it, that it's due to the work of Carl, Anne Graham here, and others, that we're building that research culture. And the particular area that Sarah is going to talk about, which is looking at practitioner identity and the Irish further education and training sector, you're seeing huge changes in the FE sector, and I have no doubt that the changes in the FE sector are going to be mirrored in the higher education sector. So this is where having the opportunity for Sarah to put forward her case is actually lessons learned for all of us, not just the students, but maybe us as managers within higher education need to sit up and listen to maybe what's happening, because some of the things are probably coming down the tracks for us. So look, best of luck to Sarah, and I'll leave it over to a person more capable than me. Thanks.
Hi, I'm going to use this opportunity to introduce you to both myself and my research. My name is Sarah Bates-Evoy, and my own personal educational and work background started with social care, where I qualified in WIT as a social care worker. I then later went on and qualified as an adult guidance counsellor, and then more recently as an adult tutor and facilitator. And although my sole purpose in life is to successfully complete this PhD at the moment, I'm also still involved with the Waterford and Wexford Education and Training Board as an adult tutor and facilitator. To give you a bit of background to my research, I aim to examine practitioner identity in the Irish further education and training sector and the impact of recent changes on those identities. And just to be clear about some of those words, FET is the phrase I'm going to use for further education and training, and practitioner is a phrase that I'm using to encompass a multitude of terms. So FET practitioners within their individual FET contexts might be referred to as lecturers, teachers, trainers, facilitators, tutors. So for the purposes of this, they're all practitioners, okay? So a bit of an introduction to the Irish FET sector. So prior to 2013, there were multiple of kind of adult education, further education, post-leaving cert contexts out there in Ireland. And in 2013, they were all amalgamated into one sector, which is referred to as the Irish further education and training sector. To date, there's very little research on that sector as it stands now, and even less then on practitioner identity within the sector. It's a hugely diverse group. These individual contexts had organically arisen due to needs within the community. So you have now a sector that's dealing with very diverse learners, students, very diverse education and training practitioners, and very diverse kind of contexts, as in some would be full-time accredited, others might be part-time contexts where no accreditation, and it's more about community empowerment. This research is quite valuable, I think, to most people in the room, as in you may at some stage choose to share your knowledge in a further education and training context. So the way that I've chosen to look at the different identities of further education and training practitioners is through a 4-stage research plan. The first stage involves a scoping event. As there was so little research out there, and my own particular experiences from within one specific context, I felt in order to begin the research, I first had to ask FET practitioners, what was important to them in relation to their identities. The next stage then was an online survey, which built upon the issues identified through stage 1. And stage 3 will be narrative interviews, which will explore those issues identified in stage 1 and 2 in more depth. Stage 4 will be where I use focus groups to present my findings to check whether the findings ring through to groups of FET practitioners who were not involved in the initial data collection. So stage 1 and stage 2 have been completed. To just give you a bit more information on stage 1, I use what's called open space technology principles to do this consultation. And what that means is that there is a team for the consultation, which in this case was who are further education and training practitioners. But there was no pre-established agenda. So the people that turned up for the consultation on the day designed their own agenda and then chose which discussion groups they wanted to participate in. There were a multitude of issues that arose, which you can see on the screen here behind me, and it was based on these issues that I then designed the next stage, which was the online survey. The online survey then was sent out to different FET practitioners across the southeast within diverse FET contexts. 167 people chose to engage with it, and they engaged with questions under 4 key headings, which you can see on the screen here. Part of the question, part of the research aim is to look at the impact of current sectoral changes upon teacher identity. And some of those changes involved the disbandment of FÁS, the establishment of SOLAS, which is the Irish Further Education and Training Authority. And one particular one which I was particularly interested in the findings was that we have what's called the Teaching Council of Ireland, which since 2006 has registered primary school teachers and secondary school teachers. And basically they are there to say that these teachers have met a certain standard and that, you know, your children are safe. And within further education and training, and also within higher education, up to 2014 there was no real structure there to register practitioners. So since 2014, FET practitioners who are delivering education and training programs within what is referred to as recognised schools and being paid from public funds must be registered with the Teaching Council. In order to do this, you have to have a level 8 qualification in your own area and also a teacher education qualification. So prior to 2014, and even since, there's a lot of people working within the sector that would not meet those requirements and would not be able to register with the Teaching Council. SOLAS, which is a kind of a core stakeholder, would very much be promoting the idea of professionalisation of this newly amalgamated sector. And one of the key things that would be seen as being part of a professional sector is that you would have professional registration body. So the option open to what's referred to as further education teachers at present in Ireland is to register with the Teaching Council. But when I looked on the ground with these people who are practicing out there within further education and training contexts, I found that only 65% of those who had engaged with the survey were actually provisionally or fully registered with the council. I also found that when I asked the question, are you eligible? Because some people would not be eligible, they would not meet the criteria, 6% of those who knew they were eligible had not registered with the Teaching Council, which just kind of might reflect on the value they placed on that and the fact that they didn't feel the need to register. Less than 50% needed to actually be registered in order to work within their FET contexts. And when I asked the question, do you think that it is important for FET practitioners to have a registration body, only 73% kind of agreed with the idea of professional registration. And of that, only 39% felt that the present option, the Teaching Council, was an appropriate body. So this leads me on to questions which will be explored within the narrative interviews around, do FET practitioners see a value in having a registration body? And is the Teaching Council an appropriate registration body? And if not, what would an appropriate one look like? I would hope that this research will contribute to understanding teacher identity and practitioner identity within further education and training, and will draw attention to the positive and negative impacts of sectorial changes on practitioner identities. I would also hope that some of the learning could be applied to other sectors that are undergoing amalgamations or where diverse groups of people are being brought together. If you have any further questions, you can take down this email here. If you have any questions about either of the 2 stages that have been completed, I'd happily address them now. Thank you.
Any questions for Sarah? Felicity there.
Thanks very much, Sarah. I just have 2 kind of different questions, I suppose. One is identity. How are you defining identity, or how are you encompassing it?
Well, I suppose we're looking at the kind of the work identities that FET practitioners would hold, and rather than going in with a set kind of definition of identity, I'm asking them to tell me what they see as their identities, which I'm finding is actually very, very diverse. So it's one of those sectors where identity means different things depending on where you're coming from. So like even the value bases and ethoses of different contexts would impact how somebody sees themselves or what they see their role as. So even what is the identities is part of the research findings.
Okay, and that's interesting. And in terms of the existing theories of identity in the workplace, are they being used as a baseline at all, or is it purely from the respondents?
Yeah, I'm hoping to actually apply Archer to understanding the different forms of identity, but I'm waiting to see what they say first, as opposed to going in with a model. Because it's so new and there is no research on it, it's kind of taking somewhat of a more grounded approach to it, as in allowing the identities to surface before I apply a theory to it. But there will be a theoretical framework, hopefully. At some point it'll be, and I'm hoping, or at the moment I see myself using Archer. Yeah.
Great.
Okay, thanks very much. I mean, to set the context, thanks to Sarah. I know she's the only representative from the school, and I want to acknowledge again, but just to maybe re-emphasize a couple of things. This actually, from an educational institution perspective, has huge potential for us. I think Sarah touched on it. She said that maybe all of us here may be involved in further education. There's nearly 100,000 practitioners in the further education sector. They're trying to professionalise the FET sector. Part of that professionalisation is identities and the qualifications that are coming. You can see it with the nature of the programmes we offer. A lot of those programmes could actually, like we have a whole trades area. There's a huge trades dimension in the FET sector, and professionalising that, the identities plus the pedagogy behind that, are areas that do reside within the institute of the school. So actually the challenge for the school, and maybe it lands on my shoulders for however long I'm still here, is how to champion that agenda further, because there's huge potential in that area. Huge potential. So thanks to Sarah and Carol, Anne and others for doing it. So well done to everyone.
Thanks, John, and thanks, Sarah, for your presentation. I now invite Dr. Michael Harrison. Michael is the head of School of Science and Computing, and I invite his presenters to the stage. Thank you.
Thanks, Emer. So we've been given the shift before lunchtime, and presenters, you have to waken everybody up again, okay? Listen, I've been given 2 minutes to give a very brief overview of research in the School of Science and Computing. Obviously, we have heard from two of the research postgraduates, John and Krita, in Department of Computing and Maths, and in this session we're just focusing on research activity in the Department of Science. Just to very, very briefly spit you out some of the facts, because we've just finished collating them for school review. Over the last 5 years, the school has graduated 53 research postgraduates, including 39 PhDs. It has a good balance of research in terms of research leading to the traditional research outputs in terms of peer-reviewed publications, and also in industry-focused and industrial research outputs. We've had 170 peer-reviewed publications, and even in the last 2 years alone, the PMBRC has engaged in 72 industrial projects to the value of over €900,000. In terms of the research priorities in the school, and particularly in the Department of Science, they're very closely aligned with the national research priorities identified in the Forfus report, and that obviously will be of assistance in securing research funding. And this afternoon here we have presentations in the area of agriculture, in the area of pharmaceutical, and in the area of renewables, and they're three of the priority areas. So I'm also delighted to say that there's a very international flavour to school life and to research postgraduate activity, and it just happens that each of the presenters are from overseas, and we're delighted to see that. It is a testimony to what other people think of us when they are prepared to come and study with us. So I will introduce the first speaker. The first speaker is Ana de Miguel Munoz. She is from Spain. She started working here in June 2014. She is working in the forestry area. She's working with the Wood Energy Research Group, part of the Eco Innovation Research Centre, and her project has been conducted in conjunction. It's multidisciplinary. It's been conducted in conjunction with UCD, with Trinity, with UL, and with Chagos, and it is funded by the Department of Food, Agriculture and the Marine. So I'll hand over to you, Anna.
Hello, I'm Anna, and I'm going to present part of my research titled Woody Biomass Unit Conversion Tool. And this is part of the short for project that I'm funded by. So the question that made me think of doing this conversion tool was, how can I quantify code resources for different markets and for different purposes? For example, in the forest, it's common to calculate the timber in cubic meters in volume. But then when timber is stacked or stored and transported, it's calculated in weight, in green tons when it's fresh, or then when it's dry, in dry tons. And then depends on the different products, we have also other different units. It can be bulk volume when we have particulates and we have air between the different particulates. We can also have calorific value for the energy products that we can talk in gigajoules or we can talk in megawatt hour. So all these different pieces, all these different parts talk in different units. It's like they talk in different languages, and they need to understand each other. For example, the foresters talking in cubic meters, and the engineers talking in gigajoules. How can they understand each other? So that's what made me think about that. And summarizing the different methods to quantify good, we see that we can quantify by volume, solid or bulk, when we count this space between the different parts. Then we have weight, can be green when the material is fresh, or dry when it has been dry for some time, or in the oven. Then energy content when we talk about combustion products, and carbon content is every time more often used with the climate change concerns. So in literature, we find these ambiguities between units and these different examples of units or missing data of how to compare to the others. So when you want to find some values and to compare with others, you find that there is lack of information and ambiguities. And there are some other tools that have tried to do this same aim, but some of them have gaps. For example, they compare just between volume or weight, not all these different methods. And also, some of them have lack of flexibility if they are just for one particular tree species, but you can't use the tool if you are looking at other different species. And others have lack of transparency, as they are like a black box where you just put your data and then you get something, but they are not educational. So the objective was to develop a unit conversion tool to quantify good for different purposes. But this unit conversion tool needs to be different from the others. So it needs to be educational to show the user how these conversions can be done, universal because it has been done using international methodology from the international standards, and flexible because the user can use its own data if he can collect it, but also provide some values if he can't collect that. Also accessible to everybody, so not using any specific software, just a spreadsheet, and then simple to use, but providing accurate information. So how I did that? First, I identified the different parameters involved in all these conversions, and I determined the inputs, the essential inputs, the conversion factors, and the output. After that, I made some tables with all these equations that made the relationship, and I did the model in a spreadsheet. Then I collected some data in the field in some eucalyptus site to have an example to use the tool and to validate the model. So first, I made this diagram where you can see all the parameters involved and all the relationship between them. I'm not going to go through all of them, but just in general, in red, you can see the different methods that I explained, volume and mass, energy. And all the other parameters are the conversion factors that you need to go from one of these quantification methods to the other. For example, in the blue circle, you see M, that is moisture content. And you see that almost all the arrows go to throw moisture content. So moisture content is one of the essential inputs in my tool. this is just an example of how the equations tables are. So in the first column, you see the input parameters. For example, if you measure solid volume, cubic meters, you go in the first row, and you, for example, want to check dry matter. You go to this equation, you will get dry matter. So all these equations are more and are the mechanisms of the tool. And I know you can't see much here, but it's just to show you that it's just a common spreadsheet, and that in the first block here, the first column, you have all the inputs. Some of them, the user always can input its own data, and also some predefined values are provided in case he can't collect that. Then you have the output in the next column, and at the right, all the calculations and the provided values are also visible to the user because of this aim of being educational. So then I collected some data in the field, and this is an example of how just measuring standing volume, moisture content, and basic density, you can get all the output, all the different measurements. And if in addition you have the value, you can get also in weight, for example, you can get the value in all the others unit. So as a conclusion, this developed unit conversion tool allows to quantify wood resources for different purposes, also making direct comparisons between the different markets as you can get the values, and allows the user to understand the parameters and the conversions as they are visible in the spreadsheet. And also is flexible because you can use your own data if you collect it, or you can use the default values. And thank you very much for your attention.
Okay, questions? Peter?
Anna, thanks very much indeed. It's a very interesting presentation. Who is the model aimed at? Is it the grower? Is it aimed at the end user, or at both ends of the market spectrum?
It's at both ends. That's why, because the problem is that each one talks in different units, in different ways, in different languages. So this model is useful for both of them, because both of them need to know how much is what the other is saying.
And the model differentiates between different species of timber as well?
Yes. Okay. You can use your particular data. It's useful for all the different species because you always can put your own data. But if you can't collect some of the data, there are some values that are grouped in broadleaves or conifers, so you can use them as well.
Okay. Thank you very much. Thanks.
Brendan?
Okay, thank you, Anna. My understanding, and I might be wrong, is that the growth patterns of tree species vary very much depending on the location in terms of the weather experienced during a growing season. So is your model specific to a particular location, or can it be adapted for different locations?
It can be used everywhere because it's flexible to the user. This was one of the aims, to be flexible and using the international methodology in the standards to be used in everywhere. I know it depends on the weather, but because you can collect your data and introduce your data, it can be in everywhere.
Okay. So that relation between weight and volume and weight can be varied depending on location?
For example, between volume and weight, the main thing is moisture content, and you need to measure that, or if not, you can approximately know what is the value in this place. That's why it's essential value.
Okay, thank you.
One more quick question. Cormac?
Thanks very much for a lovely presentation, and I can't tell you how nice it is when every day one hears of carbon emissions to hear of the opposite process for a change. I just wanted to ask, on that slide you showed of the three parameters, I think density, moisture content, and also the type of tree. For, say, eucalyptus, is it well established now that a certain, for those three parameters, we know exactly how much carbon will be sequestered? Is that tied down for, say, the 10 major types of trees, or are there large uncertainties there? Do you know?
about the carbon sequestered?
Yes, about how much for a particular type of tree.
The carbon sequestered in the tool works depending on the dry matter. So because the tool calculates the dry matter, you can know how much carbon is in this dry matter.
That's great. Thanks very much.
Okay, thank you, Anna. I should say that I forgot to say that Anna will be leaving us shortly. She has secured a 6-month fellowship in Oregon at the World Forestry Institute. So she'll be departing shortly and returning in November to finish the PhD. Isn't that correct? Yes. Yeah, more or less. Yeah, okay, the next presenter is Kavita Walia. She comes to us from Toronto in Canada. She is involved in pig research as part of the Eco-Innovation Research Centre. There is a 10-year history of WIT engaging with Teagasc in terms of pig research. The research is mainly based in Teagasc in Moore Park, but Kavita is based in Ashtown in Dublin, and the wider context of the research is that this particular project is looking at the control of salmonella in pigs, and apart from that, other research in the field has looked at pig manure for generating energy, and also probiotics in pigs. So I will hand you over to Kavita.
Okay, cool. Thanks very much, Michael, for the introduction. Good afternoon, everyone. So my presentation today is on the effect of cleaning and disinfection to reduce salmonella in the lairage environment of a pig abattoir. So before I start, the lairage, it's an area where pigs are rested before slaughter. And then near the terminology, an abattoir, it's also known as a slaughterhouse. So I'm going to be using these words interchangeably throughout. So just to give you a little bit of background, I'm sure all of you have heard of salmonella, and most people associate salmonella with chickens. Well, salmonella can also be found in the intestinal tract of pigs. And normally, pigs don't show signs of salmonella, but you sometimes will see some diarrhea in the animals. But the risk is here that salmonella can be transmitted to humans from meat contaminated, at the slaughterhouse. And so the problem here is in the lairage. So here, pigs are at risk of becoming infected or reinfected with the bacterium. And it's well documented that pigs need as little as 2 hours following exposure to a contaminated environment to acquire salmonella. So one of the ways to limit the spread and the prevalence of salmonella here is through appropriate cleaning and disinfection protocols. So typically in lairages within slaughterhouses in Ireland and around the world, they have various different cleaning regimes. So here are a few different types. As you can see, most of them use a combination of water, high pressure or non, with detergents and disinfectants. But there's been very little research done on the effectiveness of these types of cleaning regimes on reducing salmonella. So lo and behold, then, the objective of the research was to evaluate several cleaning and disinfection protocols on their ability to eliminate salmonella within the lairage environment. So we went and did the trial in one slaughterhouse in the country, and this is a diagram of what the lairage looks like. And we focused the trial on these 12 main pens here, highlighted in blue, and the reason being is that most of the pigs entering the abattoir come from these pens. So what we did was we had 3 different cleaning protocols. The first was a routine cleaning protocol, and this was done on a Monday to Thursday in the week, and it is just a typical standard protocol that consisted of a power wash, followed by an application of either a quaternium ammonium chloride disinfectant, which I'm going to be calling quack, or a chlorocreosol disinfectant. And this is kind of what a normal abattoir would do on a weekly basis anyways, Monday to Thursday. The second protocol was a more intensive, robust cleaning, and this was done at the end of the week on Fridays or Saturdays, depending on their end of their slaughter week, and that was just because they had more time to do a more deep clean. So this consisted of a power wash, application of a detergent, and then application of either the quack disinfectant or the chlorocreosol disinfectant. And then the last one was we wanted to see the effect of having a dry pen on salmonella. So 24 to 48 hours after intensive cleaning with either the quaternium ammonium chloride disinfectant or the chlorocreosol, we looked at drying. So we sampled the pens on Sundays. The types of different disinfectants. So the one, this would be on my right-hand side here, or sorry, left. The quack, this is what the abattoir normally uses currently. So we wanted to compare this to a newer disinfectant. So this is the chlorocreosol on over there. And the reason being is that has been shown to be effective against salmonella in wet environments, which is typical of pig abattoirs, slaughterhouses. So we collected samples in various times. So before power wash, we took samples of the floor and the wall, and that was just to give us an overall view of what the contamination level were in the pens. Then we took samples after power wash, after the detergent and or the disinfectants, and then again after drying. So now in terms of results here, so you can see that after power washing, the salmonella didn't decrease at all. Power washing had no effect, and in fact there was a slight increase. The reason being maybe the high pressure of the water kind of moved the bacteria around the pens. So when we looked at routine cleaning then with the quack disinfectant after power washing, you can see a decrease in salmonella in the pens to a 34%. But then when we apply the chlorocreosol disinfectant after power washing, you're able to see an even greater decline of about 14%. And then when we look at the intensive cleaning protocol, and I remind you this is only done once a week on Fridays, if you just apply the detergent after power washing, you see a decrease of about 46% into the pens. But then when you apply a combination of your detergent with the quack, we found a 17% prevalence versus a 2.2% prevalence when you combine the detergent with the chlorocreosol disinfectant. So again, you can see a pretty good decline there. And then in terms of drying, about 24 to 48 hours after use of intensive cleaning with the quack disinfectant, we were able to show about a 4% prevalence in the pens. But when we applied the intensive cleaning with the chlorocreosol disinfectant, we were able to eliminate salmonella, which was really positive. In terms of the types of salmonella, some of you might know, but there's over 2,600 types of salmonella, and a few of them would be found in pigs. So what we did was we looked at the types of salmonella present in the slaughterhouse after the various cleaning steps. So I'm not going to go through this all, but what I'm going to show is and you might be able to see, as the cleaning steps intensified, the types of salmonella decreased. So what the next option that we're going to be doing is looking to see which types of salmonella were more resistant to the various intense cleaning steps. And so now in terms of conclusions then, power washing alone was not successful in reducing salmonella. And the problem here is most abattoirs in the country only use power washing as a cleanliness step. So this is to show that it doesn't work. Routine cleaning with the chlorocreosol disinfectant after power washing was better than with the quack disinfectant. When we have a more intensive cleaning, so you're combining your detergents with your chlorocreosol disinfectant, that again was better than applying your detergent with the quack disinfectant. And drying, this is following intensive cleaning, so 24 to 48 hours, it didn't matter. With the chlorocreosol-based disinfectant was good. It eradicated salmonella. However, the practicality of this is questionable because in Ireland, it's common to have overnight holding of pigs in abattoirs. So maybe a slaughterhouse has to introduce heaters to dry the pens before introducing new pigs into the pens. And any of the implications then, we've made the recommendations to the slaughterhouse, so it's up to them if they want to take on board the recommendations and assist them in controlling salmonella. So just some acknowledgements. This work couldn't have been done without the help of the slaughterhouse and some of the supervisors, and especially Helen and Hector. It's a really big project, and this is an aspect of their large project. And that's it. Thank you very much.
Questions for Kavita? Peter?
Thanks, Kavita. Very interesting presentation.
Thank you.
I was just interested in terms of the different types of salmonella that you alluded to, the over 2,000 different types or whatever. In terms of the cleaning regimes, is there any particular feature of some of the types that give them that ability to resist
if I go back really quickly, so some of them here, like the monophasic typhimurium, that's really standard. You see that in pigs nowadays, especially in Ireland and in Europe as well. So they're thinking that that might be a more evolved strain of typhimurium to persist in pigs. So it might be able to stay in a drier environment more than anything else. Brandenburg here has been shown to be found in desiccated environments, so dry environments in outbreaks. So it's interesting that we were able to find Brandenburg after drying in these pens. So what we're doing now is to see if they create biofilms to keep them sustained in the pens after the various intensive cleaning. So I don't know yet, but when we get the data, we'll know.
So is there a possibility that the drying may actually spread the bacteria, if you like, to grow those particular types of strains?
Yeah.
Okay, thanks.
You're welcome.
Excellent presentation. Thanks very
Thank you.
much. I really enjoyed it. I just want to ask 2 short questions.
Sure.
The first one is, if you could explain again how the bacteria can transfer into humans, and secondly, in relation to the very last point you made, your recommendations, I'm wondering are there certain minimum standards that abattoirs have to abide by, and how might the impact of your research be felt, I suppose, in practice?
Sure, I can answer the last question first. So there isn't really a standard protocol. The Lairge, so in slaughterhouses, in food manufacturers, called HACCP. And normally those are critical control points of food safety, and the Lairge really isn't a HACCP critical control point. What the first critical control point in a slaughterhouse would be their hot water bath. So this is just a thing in slaughterhouses, just to say, if you're able to control the salmonella in the slaughterhouse at that initial point, maybe it's a hurdle effect. So maybe down the line, all the other hurdles that the control points that you put in the slaughterhouse, at the end of the day, then the meat that you get would have less salmonella. So really, at the end of the day, if you cook your product properly and you handle it properly, then I, in theory, would be out of a job, because there'd be no food safety issues. But that's not the case. So it's really up to the slaughterhouses if they want to implement that. It's good for them because they can show that they have less salmonella in the product at the end of the day. But we can't force them to do anything. So whether industry wants to do that or not, I don't know. And in terms of how salmonella is transmitted, well, normally it's when you get an infection anyway. So if you have to eat your contaminated meat, it would depend on various factors. How healthy you are. You might it's self-limiting. Normally, salmonella in humans, you just get the runs, and then after a few days you might be okay. But it's an issue with people who are more immunocompromised, so that are more either the elderly or the really young. They could end up in hospital, and you could die, but it's very, very rare. So I hope that answered your questions.
Okay.
Yep.
Thank you.
Thank you. Is there another?
One question before you finish. Yeah, sorry. It was an interesting presentation. Just 2 aspects to it. Did you consider the cost effectiveness of the different approaches, and also the actual implications for the environment of such a large amount of waste, and especially from a water disposal?
Fair
and
enough.
the sort of chemicals you're using?
The cost is, so the slaughterhouse only uses this quack disinfectant, so they get it at a reduced rate anyways. The chlorocreosol, it's a newer product. It's not really marketed for pig abattoirs at the moment, so the cost that we got it at was at a commercial rate, but it would depend on the slaughterhouses trying to come up with a cost with the manufacturer. So we didn't come up with a cost for that. On another trial, we have cost benefit for the organic acids, but not for this one. And in terms of the water usage, honestly, I don't really know. These are pretty dilute, in dilute quantities. So in theory, they shouldn't have an issue, but I don't know if they will have in larger quantities. I'm not sure. I can't answer that. I'm sorry.
Thank you.
Thanks, Kavita.
Thank you.
Now, our final presenter in the science section is Cordula Weiss. Cordula is from Germany. She did her BSc and MSc at Ulm University, and she has been working with the PMBRC group since November 2014. The whole area of drug delivery and pulmonary drug delivery is a particularly important area of research within the PMBRC. this whole area of research started as a collaboration and innovation partnership involving Teva and Merck as industrial partners 5 years ago. And Cordula is funded by, she's actually funded by the WIT PhD scholarship scheme, but other elements of the research would be funded by Teva and industrial partners. And the tagline for this research, I'm told, is quality by design, and what they're hoping to do is to understand the basics to improve the final product delivery. Okay, so Cordula, I'll hand it over to you.
Thank you. Okay, thank you, Michael, for the introduction. Good afternoon, everyone. So what I'm going to talk about now is dry powder inhalation, specifically the preparation and characterization of beclomethasone dipropionate for inhalation. And just to give you a short outline, I'm going to introduce you to the principles and the mechanics of dry powder inhalation first, to give you an idea what I'm talking about. Then I'm going to move on to tell you a bit about how we can influence the quality and the performance of a dry powder inhalation formulation. And then I'm going to move on to my own research. So dry powder inhalation, how does it work? I think most of you probably know what an inhaler device looks like. Some might even use it every day. It comes in different shapes, different sizes. But what a dry powder inhaler has, like what each dry powder inhaler has, is the dry powder formulation, of course, which is made up of an excipient, which is the carrier material, usually lactose, and of course it also includes the drug, the active pharmaceutical ingredient, short API. So here on the image you can see the large gray shapes, which stand for the lactose carriers. They are about 100 microns in size. And you have the small particles, the blue ones, which is the drug, and this is stuck to the big carrier particles. And the only reason the two of them stick together is actually the adhesion force between the lactose and the drug. So you might wonder how this kind of detaches again, because at some point you want to have the drug in your lung where it's therapeutically active, and you want the lactose carrier to get out of your body again. So what happens is when you inhale the whole formulation, the carrier particles and the drug particles stuck to them, the power of your inhalation and the drag force and the kind of impact the whole formulation has when it hits your respiratory tract, and also the turbulences in the airstream when you inhale, this all causes the detachment of the drug particles from the lactose particles, so that the lactose particles can be exhaled again because they're recognized as foreign bodies. And the teeny tiny drug particles, which are about 1 to 5 microns in size, they move on through a respiratory system and end up in the lung where they are active. So the upshot of what I just told you is actually that the adhesion between the big lactose particles and the small drug particles is important and is crucial for the quality and the performance of your formulation. And the adhesion between the carrier and the drug, also between the drug and the device, and the cohesion between the single drug particles, that's all governed by the particulate characteristics. To give you an idea, it's like the shape of the drug particles has an influence on that, the size, their morphology, the surface energy and the surface area, also the roughness on the surface of the drug and the carrier, also the crystallinity and the crystal structure, and in some cases there might be some charging on the surface. So all these characteristics, the morphology, the structure, and so on, they all can be kind of changed if you change the processing parameters. So if you manufacture a drug for dry powder inhalation, all the way through from scratch up to inhalation, everything that happens on the whole way impacts the particulate characteristics. So it's the processing parameters, it's the crystallization parameters, it's the way you store the drug, how you micronize it, how you dissolve, how you make the dissolution, and it's quite a lot. And that's actually the choice of the material scientists, because what I'm working on now is exactly looking at the processing parameters and how you can influence the processing parameters, then move on how the processing parameters influence the particulate characteristics, and how these, again,
influence the adhesion, the cohesion within the formulation. And I'm working with the drug which is called beclomethasone dipropionate, short BDP afterwards. Looks like this. It's a steroid and it's an anti-inflammatory drug. It's used in asthma treatment. What I did first was creating or precipitating BDP solvates. A solvate means that I have a crystalline structure, and inside this crystalline structure I have channels or voids, and inside these voids again I have solvent molecules. For example, acetone, which is the first picture, or different kinds of alcohols. So what you can see here on the top row, that's all the solvents I used. So one of them is acetone, and the other ones are just different alcohols. And I'm using different characterization methods. One of them is the scanning electron microscopy, just because it gives you a nice image and an idea of what the particles look like, and it also gives you an idea of the size distribution. But of course, we use a combination of different characterization methods to get the full idea, the full picture of what we are doing here. But what you can see here, for example, is that these particles there have like a really rough surface, and they're more like flaky compared to these ones here from the ethanol, which seem to have like a smooth surface and more regular shape. Or back here, these two from butanol and pentanol, they're very irregular and again, large size distribution, and they tend to form agglomerates. So I used some more techniques to look at all that in detail. I'm not gonna go into techniques in detail again, so it's just like thermal analysis, FTIR, gas chromatography, and mass spectrometry, XRPD, atomic force microscopy. So I'm not gonna give you all the details. Just here, to see what we can do with atomic force microscopy, we can look at the surface in detail. We can see that one of them is rougher than the others. This one is really smooth and a really nice crystal, for example. That's the one coming from the alcohol, from the ethanol. Or we can see here, it just gives us an idea of what this exactly looks like. Another one would be DSC. It's thermal analysis, and it shows you that here at these points, these signals shows you that the solvent is actually leaving the crystal at some point at a certain temperature, or it shows you that there's some transition taking place. So what I did in conclusion is I prepared 7 different BDP solvates, characterized them, and looked at the choice of how the choice of solvent actually impacts my particulate characteristics. I did stability studies to see if they're suitable for storage, and I used desolvation techniques to obtain the anhydrous BDP. What I'm going to do next is I'm going to select some promising solvates. I'm going to optimize my processes, my parameters, and I'm also going to look at the behavior in the formulation using a next-generation impactor. I'm looking at the adhesive and cohesive forces, again with atomic force microscopy. And in the end, I'm hoping to get an idea of how the processing parameters affect my particulate characteristics and the interparticulate forces. So I'd like to thank my supervisors, Helen and Peter, and also everyone from all the groups in WIT and TCD and also UL who helped me with the experiments. And thank you for your attention.
Thank you, Cordula. Thanks. Questions? Okay, Cormac.
Thank you very much. I was hugely impressed by the number of different techniques you used. I remember as a postgrad, we were lucky if we would get 2 out of those. It says a lot about the group and about the college. That was my first question, actually. Were they all used here? Are they all, including the AFM, were they all done here?
The AFM,
all
yes.
The techniques, yeah. And
it's actually a really good one. It's fairly new as well, but AFM is perfect, yeah.
Can I ask, does it take long to be trained in to each one of those techniques, in particular the AFM?
Depends. The AFM takes a while, so I think you need quite a lot of training to use it, and especially to use all the different methods, especially the colloidal probe AFM, because you have to glue, like I told you, like the particles are about 5 microns in size.
That's right, yeah.
And you glue these tiny particles onto an AFM cantilever. And you have to develop a technique to do this, and then also to calculate afterwards, like how the position, for example, of the particle on the cantilever influences your results and all these tiny details. So this really takes a while.
Yeah, it's
but
very
then XRPD, for example, was done at University of Limerick. So I don't care about, well, I do care, of course, about how they do it, but they do the measurements, and I'm not trained on the technique, so I just know how to interpret the results.
It's very impressive because typically in materials science, the big problem is waiting for other people to do particularly the sample preparation, you know, and if we can do it ourselves, and if each researcher is doing it, it really kind of makes for very good publications where you've examined it using lots of different instrumentations. It really is amazing.
Yeah, thanks.
Okay, any other questions? All right, thank you, Cardula. So listen, well done to our three presenters, and I'm glad to say we're more or less on time. So timekeeping police are doing a great job down here. Okay, so enjoy lunch, everybody.
Thanks, Michael, and thanks to all our presenters so far. So now I'd like to invite you all to lunch and to the poster viewing session in the atrium. Just to remind our presenters, our poster presenters, please stand by your poster, of course, after you've had some lunch. Just to remind you that the poster judges and the delegates here today will be going around to talk to you about your poster, and they'll also be choosing the winner. Also, please remember to hand back your voting slip to one of either myself or one of my colleagues in the RSU on your way back into the auditorium, because the voting will close just after lunch. And finally, if I could ask you all, please be back in here by 2:10 p.m. for the final oral sessions and for the 3-minute thesis competition. Okay, thanks, and enjoy your lunch.